In this video, we'll be adding some large rational expressions. We have m minus 1 over m squared minus 4m plus 4 plus m plus 3 over m squared minus 4 plus 2 over 2 minus m. I have some space in here because I'm going to be doing something to this fraction or rational expression so that we have a common denominator. We have to find a lowest common denominator before we can add or subtract fractions, and all rational expressions are large fractions. So what is this lowest common denominator? Well, we can factor each of these. I'm going to try to do this right under the fraction here. This is m minus 2 times m minus 2. This one is m plus 2 times m minus 2. And this one is 2 minus m. I'm going to, at this time, factor out a negative 1 and say negative 1 times m minus 2. Because I want it to look like these other factors. So, what can we do with this negative 1? Well, this is in the denominator now. We can also just get rid of it in the denominator and write it in the numerator. So, now we have a negative 2 in the numerator and m minus 2 in the denominator. Now that's, for a lot of people, that's the largest step in this problem because it really throws people off, understandably, when it's written backwards like this. Okay, that LCD now. We have an m minus 2 and an m minus 2 here. We have two of those factors. We have an m plus 2 here. We have an m minus 2 here. So what we need is an m minus 2 times an m minus 2 times another m plus 2. So I am going to multiply this fraction, and I'm going to just kind of cross this stuff out and work with what's in red there. Okay, I'm going to multiply this by m plus 2 over m plus 2. And on this fraction, I'm going to multiply this by m minus 2 over m minus 2. Because that is the factor that is missing here. All right, and over here we're missing an m minus 2 and an m plus 2 factor. So I'll do that. M minus 2 times m plus 2, and in the denominator, m minus 2 times m plus 2. All right, now we need to multiply what's in the numerator here. So I'll kind of jump to that a little bit quicker. M plus 2 times m minus 1, we have m squared, and then you have a minus m plus 2m gives you a plus m. 2 times negative 1 gives you negative 2. Over that LCD, I'm going to write, instead of writing all of this, I'm going to write LCD. And we will come back and write those factors when we need to. Plus m plus 3 times m minus 2, that's going to be m squared, plus m minus 6 over our LCD, our lowest common denominator, again, that we have here. And then be careful here, we have a 2 multiplied here times all of this. So what I'm going to do is I'm going to multiply this and write that as m squared minus 4, because that's what m minus 2 times m plus 2 is. Now we can distribute the negative 2. So we have plus negative 2m squared, and negative 2 times negative 4 is positive 8. Again, over the LCD. Now we can clean up this stuff in the numerator. So we have, let's see, an m squared, and a negative 2m squared. So those will all get knocked out. That's kind of nice for us. Makes the factoring easier later on. Now we have an m plus another m, so we have 2m. Let's write that. 2m. And in fact, I'm going to change colors and go back to black here. 2m. Now we have negative 2, negative 6, and positive 8. Looks like that's going to be Negative 2 and negative 6 is negative 8, and a positive 8 will give us 0. So we just have 2m over this large LCD, which was, again, m plus 2 times m minus 2 times m minus 2, and the comment I get from students is, why did we do all of that work when it just simplified to something small? Well, the answer is because sometimes you do start with something complicated, and luckily it can simplify to something a little bit smaller in the numerator anyway. The denominator is maybe more involved. But that is the answer to this large problem of adding rational expressions. I hope that helps.